In this lesson, we're going to talk about similar polygons. So previously, we've talked about congruent polygons and then specifically congruent triangles. So now similarity is going to involve the idea of using proportions. So just as a review, when we solve for proportions, we're going to cross multiply. So we're going to end up setting up these fractional components to these problems and then using our cross multiplying skills to solve. All right, so now the specifics. Here we go. Similar polygons are two figures that have the same shape. So if they're both triangles, but not necessarily the same size. They're going to be called similar if they're the same shape, but not the same size. All right, and then the criteria for similar is they must have corresponding angles and congruent corresponding sides that are proportional. Okay, so we have, again, corresponding angles. That means the angles are the same, but the sides are proportional, right? So every side has to be proportional in the figure to the other side in the other figure. And we'll go through some examples in a minute. All right. And then the ratio of the lengths of the sides is what we call the similarity ratio. All right. Now up here, if you guys notice in the first bullet point, this little symbol here is the similarity symbol. We see this symbol on top of the equal sign for congruence, but right now they're not congruent. They're just similar. So we'll start to see this in some of the examples and problems that we have in this section. All right, so here we go. This example one, this statement right here looks very, very close to what we've seen in the past. This is a similarity statement. In the past, we've used congruency statement, but there's no equal sign here. So the difference between this and a congruency statement is the equal sign. So no equal sign means they're similar, but the rules are the same. A would go with X, B would go with Z, C would go with Z. So in this case, angle B is going to be equal to angle Y. So if we look over in the diagram here, we see that B would go with Y. So angle B has to be 78 degrees. All right, now over here, if we look, BC are the last two letters, okay? And the last two letters are YZ. So we set them up in a proportion, okay? So then XZ are the first and the third, and they have to be partnered up with the first and the third. So there's two different ways to set up these ratios. One way is the left triangle divided by the right triangle, and that's the way they did this particular problem. So again, the part in the left triangle that matches to the part in the right triangle. Okay, here's another example. Again, what is this thing called? This is called your similarity statement. So what partners up with E in this case? It's going to be angle A. So in the diagram, angle A is 53. So we know E has to be 53. All right, so in the ratio setup here, we have AB, which is on the left quadrilateral, is partnered up with EF on the right. So AB over this. So AD is going to be partnered up with EH. Okay, so this idea shouldn't be too different from what we've done in the past for congruency. All right, next, here's our similarity statement, and we want to make sure we match things up. So here's how we're going to set this up here. All right, X is part of AC. So if you guys look for the variable, it's part of AC, so it's going to be over here. Right? And AC is partnered up with YZ. Okay, AC is partnered up with YC. So what is YZ in this case? It's 40. So I'm going to show you a different way to set this up. Now this time, X on the left is partnered up with what on the right? Okay, this is one way I prefer to set this up. You can do it the other way, where the left triangle divided by the right. I'd like to keep all the values on the left, and all the values of the right image on the right. So X partners up with 40. Well, what does 12 partner up with? So here is BC, all right? And in our statement, BC partners up with XZ. So down here, XZ is 30, and so they partner them up. Now, how do we go about solving this? We're going to cross multiply. So 30 times x is equal to 30x. 40 times 12 is equal to 480. And then we would divide both sides by 30. So again, cross multiply and then divide to get our variable. And in the directions, they just want the value of x. All right, let's look at the next one. Now, the next one's a little bit different because on the left image here, the left figure, they give you 3 lengths, but on the right, they only give you 2. So this is a sign that there's going to be something extra we don't really need. All right, so they want you to find the value of x. So step 1 is to figure out what x is. Well, x is part of st. All right, st is the last 2 letters, and that's going to be partnered up with no. So x and 2 are going to go together. So the left value is 2, the right figure value is x. All right, well, what goes together with the other figure? So there's 2 lengths to pick from to go with this one. We have to figure out which one it is. So QR on the right is LM on the left. So we're going to use 5. Now we cross multiply. We get 12 equals to 5x, and then divide, and we get x equaling to 2.4. All right, so that's how we do these problems. To find the angles, angles are congruent, so that doesn't change. We still would use everything we've learned in the past about angles for congruent angles. For the side lengths, though, the difference is we're going to set up proportions, cross multiply, and then solve for the various variables.